So I want to give a quick introduction about my profile. I'm Akkhil. I work for Bank of Montreal, and I'm heading their data analytics, AI, and robotics team for their personal and business banking side. I I have a risk management background when it comes to my academics. I have a risk management background from University of Toronto. I've recently completed an AI program from uh, Northwestern University, Kellogg School of Management. So without probably taking much of time, first of all, I want to thank everyone for joining this evening. And what I'm actually trying to cover this evening is the AI, machine learning, data and cloud, and DevOps, and how that model pipeline that we are actually using with the help of DevOps in the next in a few minutes. So just to give an overview of what probably we're going to cover in this entire session is we're going to have an overview of the AI, machine learning, data, and DevOps. They're going to cover how we're going to prepare the data and how we're going to look at when it comes to building the model. What are we talking about that? And then also, what is the role of DevOps, in the AI machine learning, and also from an industry perspective at the end, how the end-to-end data flow for Google, how they're using DevOps. So to begin with, and I think the overview of AI, machine learning, data, and DevOps, that's what the first thing that I would like to cover. So when I look at the whole concept of DevOps, 5 years ago, DevOps was pretty much like a game changer, which is almost like it is still a game changer for a lot of the organization. And one of the things that I have actually experienced, in the leadership role in technology is that anytime when we talk about change, we talk about a whole lot of mechanism. It involves different groups that are part of it. It can be a business stakeholder. You have a technology stakeholder. There's a lot of different elements that actually comes into picture when you're thinking about actually delivering a product, for the end user. And DevOps actually, in the application world, it actually helps to integrate all these different people, processes, and tools and technology combined together in a very finite state, so that we are able to deliver in much shorter time. So in reality, the difference that makes with somebody using DevOps versus somebody don't using DevOps is that the one who uses DevOps is actually able to deliver much faster. Their lead times is much faster, and also they're much more comprehensive with their approach in delivering the output. Now, with DevOps, I believe one of the key factors that actually I would say propel the growth of AI and machine learning is that earlier, when you wanted to stand up an application or when you want to stand up or deliver a product, you think about you have to think about a lot of infrastructure deliverable that needs to come along, which means standing up your own server, standing up a team that can actually deliver a change management process. Now, with the introduction of cloud and DevOps, what it actually done is actually simplified this entire segment for every user, and that's what we're going to cover in the next few slides. So if you look at in this current one that I'm sharing with all of you guys, is that you can see that it's the journey when it comes to AI and machine learning. It starts with with your data. Data is actually the fuel for AI, and we wanted to make sure that we stay focused on preparing that data. And once that data is actually prepared, then you're actually going through a whole lot of experiment. That's basically the model building that I would say, and that is actually a little different than your usual test case executions per se, because here you're trying to test the model. You wanted to make sure that the model is actually working and giving you the input and output that is actually you're working towards for it. And then once you actually get, once you train and test the model, if it has been able to achieve, a certain level of acceptance level, then you actually proceed to, deploy and, share that with the end user. So coming to that, the very first step that I mentioned, preparing data. So as I mentioned, I work for Bank of Montreal, and one of the core areas that that I have actually experienced, as a technology stakeholder, is that preparing this data is probably the most critical part, in the journey of AI or in machine learning, because it is so the output that you're looking out for, uh, it is so finite that you wanted to make sure that you don't want any unnecessary elements of data out there, because earlier people say, okay, I want to have more data out there. I need more data so that I can do my analysis more. That is fantastic. But however, when you're building a model, you also have to make sure that you're collecting, you first need to have a definition of why you need this data analysis, and what are you looking at to trying to achieve for it. And then what matters is, then you start collecting from the data from the various sources. For example, if you're trying to collect, credit card information, you will be looking at, the sources that can actually help you with the credit card source of, data for you. And if you're looking for, the retail transaction, or the checking, or savings, or any of those transaction related information that you're looking out for, you need to make sure that you're taking that information from those kind of sources. And then once you identify these sources, as I mentioned, you're going to get a lot of data for sure. And the cleaning this data through, and also making sure that what you have is the right data, that is the most complicated area that I would say. And once that is done, then you actually began the analysis through this data, and make sure that you can interpret this data in what the actual end user is looking for. So for me, the preparation of data, I think this is the starting point, wherein this is probably the most critical input for me into the entire segment, that which you're looking at it. And this journey starts even before, we start leveraging, DevOps or any of other tools. Once this data analysis is actually done, then we look at, okay, what kind of a model that I'm trying to build here. And am I going to use, the buzzword in the industry right now is it going to be supervised or unsupervised? In my experience so far, I have always, been more leaning towards supervised machine learning. Not necessarily that, unsupervised, is not, preferred. The advantage of supervised learning is that you have a control on what is actually the output that you're looking at. And that gives you a lot more leverage, in the initial phases wherein you are trying to build a model that actually fits into, that you're looking for. And also it has advantages wherein you can control the input and output. And that's basically is what most of the organizations are also looking forward for. Because at the end of the day, you want to make sure that you build an algorithm or build a model which is much beneficial, for the business, that you're looking out for. It can be anything starting from, you're pricing a product, or you do, sharing recommendation for your product. All of that needs to have that kind of a control, in place. So while talking about this, one of the interesting, thing that I've learned, recently was 35% of Amazon's sale actually happens through the recommendations that the customer gets. So which means each one of us, when we go to the Amazon portal, we are basically purchasing more based on the recommendation. And I think, so those are the kind of, merits that you'll see, with the controlled, supervised, algorithm that, when you're trying to build. And also it gives you helps you to build a much more stronger, predictive model. Unsupervised, one of the key things that I would probably say is it helps in the area wherein if you're trying to implement, any fraud detection mechanism or anything which is probably, that there are more number of new elements or new cases are getting added, those are the ones that mostly people use for. But I'm probably the one who leans towards, the supervised, sort of machine learning. Coming to that, now we talk about, the preparation of data, we talk about the model, and here comes the, the most interesting element of, our conversation, which is basically the DevOps. As I mentioned earlier, when it comes to the AI and machine learning, the testing is probably the most critical area wherein a lot of people actually get confused. What am I testing it against? Am I running is it like same thing like how I build an application wherein I run test cases and I get an output and I'm good with it whether it passes my criteria or not. It's a little different here. You do have, yes, definitely you do have test elements, you do have test cases, but here you're basically trying to test and validate the model. You're not actually running it against a specific scenario whether that is actually working. Basically, your model is actually your goal, and improving that model is going to be your iteration that we are looking at here. So here in this case, I just give an example of how the Azure DevOps that I've actually been able to capture. So one of the key factors, if you see here, is that it all starts with the data, and then you look at it here that we're talking about training the model. That's when you start to build the app, and then you validate the model, and that's when you go to the deploy area. And then once you deploy, then you actually keep on monitoring whether you need to retrain this model for better performance, and whether you need to ingest new data so that you can actually validate that better. So those are the things that actually come into the the picture. And one of the things that you probably need to also will be like wondering is that how can I actually make sure that all of these changes can actually go in quicker and faster, so that I'm not actually looking at a typical of a 2 to 3 month cycle to get one validation done. And I think that's what the power of DevOps is actually coming into the picture, because you're able to validate several models. You're able to validate several models. You're able to train several models, and you're also able to train these models over and over again with the help of DevOps. And there's also certain architecture like container architectures that that is getting more popular, wherein you are also allowed to deploy multiple applications without impacting your platform, regardless of whichever platform that you're talking about. So those are something which I feel which is going to fast track the AI and machine learning in future, because as I mentioned before, cloud has actually helped a lot of organizations to deliver faster, because you're not longer worried about how I will be standing up my own server, how I'm going to do the maintenance. That is actually so that pain is actually being taken care of with the introduction of AWS and Azure. So they are actually helping to take care of that for you. And what you can actually build on is basically on building the models, which can actually help to improve your business decision, your application performance, and also introducing much more advanced products for your customer. Products doesn't necessarily have to be a financial product. It can be any product segment which can influence customers' decision. And also towards one of the exciting end-to-end flow that I mentioned here in my next slide is this is actually from Google, wherein I've been able to capture this. This is kind of the flow that Google actually follows for their DevOps, and this is end-to-end cycle. And I think it's pretty much like the similar one that I mentioned earlier. So they have an ingestion, they prepare the data, they do have something like a pre-process, and they actually they do have a pre-process and discover, which is something which I feel which is a little different from other organization. And one of the reasons why they actually do a lot of these pre-process and discover is that Google on average deploy thousands of deployments in a month, and in a day you can actually say that in several hundreds. So only thing is that's actually consistent for Google is basically change. And with GCP, they're actually doing a fantastic job, because this pipeline actually helps them to make sure that they're actually on track with what they're actually looking out for, from the either from the Google Ads or any of their products which they're offering to the customer. They're able to make sure that they're able to train that quickly and also analyze and improve on it. And they use quite a bit of heavy mix of supervised and unsupervised training models. And Google doesn't rely on just one set of the preparation. They actually use different mechanisms for preparing the data, and also the training models which they use also extensively, quite diverse.
How do you how do you version control IPython notebooks? Do you track the notebook cache, the previously executed code block in Git?
So in fact, we don't use Git, in my current organization. But version control that which we can use is, and one other thing that I recommend is use in fact a container architecture. So in that way, your Docker image will help you to make sure that you don't have to worry about the multiple the deployments that you're doing for an application. So in that way, you are actually in much better control of your platform, and you don't have to worry about whether my application deployment is going to impact any of my other applications. So that's the beauty of the container architecture, and I strongly recommend that for all the AI machine learning projects.
Anwar has asked, would you mind talking a little bit more about how BMO is handling machine learning ops and DevOps for machine learning?
So uh, again, we're all kind of pretty much early into the phase of machine learning, and we're adopting DevOps quite closely. Um, in terms of how we're actually managing it, we go through the DevOps cycle quite extensively, which means there is a stringent mechanism in place for any of the changes that which we are introducing to the platform or to the environment, and also to make sure that especially the training the model perspective. So this model is kind of actually goes through a very rigorous cycle, and as I mentioned before, this is an extensive integration between business and technology stakeholders. So it's not just a standalone feature. So we focus heavily on the system integrators testing the SIT and the UAT quite seriously, and that's basically like the main element for introducing any other change. So on that front, yes, we use DevOps quite extensively, and we ensure that there's participation at both levels, which is basically business and technology for me. Sure.
Another question from Philip. He said, when do you use the base layer for your containers? And then he said, Debian.
Okay, so I think it actually it's always preferred that to have the base layer I would say at a master level, which means I would probably recommend that if your organization probably don't have a standard set of your platform already there, so it's better that you probably try to use it, maybe create an image before you actually start working on any of the AI machine learning initiative, or probably create a separate standalone environment for your deployments. So in that way, you're not actually mixing up your AI machine learning journey with your regular application journey. So it's purely going to be based on how your organization is comfortable with.
Great. Thank you. We have a question from Yang. He said, for data and model versionings and tracking, what services or software do you find most useful and easy to work with?
Interesting question. If I probably recommend, you may probably think that okay, I'm actually favoring somebody. I when it comes to the data and model versioning, I probably Kubernetes is one of the versioning that I probably like, and I think it's really good. You can probably and also Kubernetes along with Docker engines is probably a very strong formula for success. But there are several players out there in the market right now. So you can definitely look at what actually suits you, because not every product is probably intended to give you the best results, and you have to look at in terms of what actually it's driving your end user for. So you probably your need may be different. For example, what an Uber user is looking for is not probably what an online banking user is looking for. So you have to look at the difference in terms of the agility of the platform that you're dealing with, and then you probably have to take a call. But yes, one of my suggestions is definitely going to be Kubernetes and along with Docker.
Raphael has asked, what is the average time to put the model in production after your data scientist finished the feasibility discovery stage of the project?
Okay, great question. Uh, I always prefer to have a 4 to 6 weeks lead time for delivery. But having said that, it's not always going to be a 4 to 6 week. But the average that we look at is about a 6 weeks lead time. But however, we do have quarterly release plans, so we do try to lean on to the quarterly the release plans and make sure that we align to it. And quarterly release plan is just once in a quarter. But usually that doesn't mean that we probably would wait until that quarter plan. If it's a standalone delivery, it doesn't have to wait for that period. But definitely 8 weeks is what I'm looking at.